Imagine for a moment. A real time traveler.
Hmm.
But not from, the future or the past here on Earth. Think deeper, from the darkest parts of space itself. A relic maybe even older than our sun. And it's just swinging by our cosmic neighborhood for a visit. That's what we're diving into today. This
Yeah.
incredible, newly found interstellar comet 3I to Lass. Yeah, this icy visitor. It's got astronomers everywhere just buzzing, totally captivated. So our mission for this deep dive is to unpack why. Why all the excitement? And what could it possibly tell us about, well, the origins of our whole galaxy? We've gathered a whole stack of really fascinating research, recent findings to walk us through its story. Okay, let's get into it.
What's fascinating here, what's really remarkable, is that this isn't just, another comet. Its age, its unique origin. It means it's basically a cosmic time capsule, literally. It could be carrying secrets from a time long before our solar system even started forming. Untouched secrets. It's giving us this, unprecedented glimpse into the really early universe.
And what a visitor. So, 3I Iasas, it's the latest interstellar comet we've spotted heading our way. And initial observations using spectroscopy.
Right. Analyzing the light.
Exactly. To figure out what it's made of. That's already confirmed. It's just packed with water ice. Loads of it. And tracing its path back, well, that points to an origin in the Milky Way's ancient thick disk.
Which is a population of much older stars. They orbit sort of above and below the main flat plane of the galaxy where our sun lives.
Okay, but here's the bit that really blows your mind. Could this thing, this icy relic, actually be older than our sun by over 3 billion years?
Potentially, yeah. We're talking maybe 7 billion years old.
7 billion. That would easily make it the oldest comet anyone's ever observed.
And its trajectory coming in, that alone tells us so much. It's screaming towards us at 68 kilometers per second,
Wow.
diving in from the direction of the Scutum-Sagittarius border. And its orbit around the galaxy is incredibly steep, very different from anything born in our solar system.
So that's the clue.
That's a dead giveaway, yeah. It tells us it came from somewhere else, specifically from that ancient thick disk population of stars. It's not just wandering randomly. It's on this very specific ancient path. Its speed, its angle, it all confirms that deep space origin.
7 billion years old, though. That number is just... It's almost impossible to wrap your head around it. How can we possibly know something is that ancient? I mean, what's the certainty level on a claim like that?
That's the crucial question, absolutely. And it brings us to some really groundbreaking work by Dr. Matthew Hopkins, the University of Oxford. You see, for comets from within our solar system, like Halley's,
Right, the familiar ones.
their age is kept, basically. They formed with our solar system, so maximum 4.5 billion years old.
Okay.
But for visitors from outside interstellar objects, we need a whole new toolkit.
Yeah.
So Dr. Hopkins and his team, they developed this thing called the Itahahi-Oxford model.
Total Oxford model.
Yeah, it's a new statistical method.
Yeah.
It cleverly combines super precise star movement data from the Gaia Space Survey
Gaia data, right?
with our understanding of galactic chemistry. How the galaxy's chemical makeup has changed over billions of years. It essentially creates a kind of cosmic clock. Helps pin down when and where an object likely formed.
Yeah.
And the early results for 3I Atlas using this model, they're pretty striking. It says it's very likely older than any known visitor.
Wow.
Which raises another big question. If it really is that old, what exactly has it preserved from way back then?
That really does give you pause. It's incredible. But okay, putting aside its ancient history for a sec, what can we actually expect to see as it gets closer? Because this isn't just history, right? This is happening now. It's an active event. The big moment we're waiting for is perihelion. That's October 29th.
Its closest approach to the sun.
Yeah, it'll get to about 1.36 AU astronomical units.
So still further out than Earth, but close enough for the sun's heat to have a big effect.
Exactly. As it gets nearer, that solar heat is going to start vaporizing the ice. Vigorous outgassing, they call it.
Turning ice straight to gas. Sublimation.
Right. And that's what we think will make it develop a bright coma, that fuzzy halo around it, and probably a long tail too.
Much like the comets we're used to seeing from our own system, potentially.
Yeah, for sure. And observatories all over the world, they're already gearing up, getting ready to track every little jet, every dust plume this thing spits out. It's a really exciting time if you're an astronomer.
And its arrival isn't just exciting, it's also incredibly significant scientifically. It acts as a benchmark.
Benchmark? How so?
Well, it's a benchmark for future interstellar discoveries. We've got powerful new instruments coming online, like the Vera C. Rubin Observatory.
Oh, yeah, Rubin. That's going to be huge.
It really is. It's projected to find maybe up to 50 interstellar objects, maybe more just in the next decade.
50, wow.
So 3I Attiles gives us this fantastic early chance to really hone our techniques. How do we best track these things? How do we study them effectively? We had visitors before, of course. There was 1I Oumuamua.
The really weird cigar-shaped one.
That's the one. Very mysterious. And then 2I Borisov, which looked much more like a typical comet.
Right.
And each of those surprised us in its own way. They sort of set the stage, building anticipation for what this next one, 3I Attiles, might reveal.
And that really is the heart of it, isn't it? As we get ready to metaphorically peer inside this icy time capsule, what are we actually hoping to learn? What secrets could it spill?
The scientific potential is just profound, especially because of all that water ice we mentioned.
Right, the water.
Water ice is amazing at preserving things. It can lock away chemical fingerprints for billions of years, eons. So by analyzing the stuff coming off the comet, the coma, the gas, the dust, researchers hope to find clues about how planets formed in the very early universe. Not just here, but potentially far beyond our own solar system.
So like comparing its chemistry to ours.
Exactly. For example, if we measure the isotopes in its water, different flavors of water molecules, and find they're really different from what we see in our solar system, that could strongly suggest there were distinct reservoirs of water in the early galaxy. It might challenge some of our basic ideas about the conditions needed everywhere for planets to form. And if we connect this to the bigger picture, well, it leads to a really grand question.
Which is?
Could interstellar comets like this one, like 3I Atlas, actually be the key to understanding how water, and maybe even the basic building blocks for life, got spread throughout the entire galaxy?
Wow, that's a truly mind-bending thought. Just imagine it. This chunk of ice and rock floating in the dark, the cold, for billions of years. Then suddenly, this bright star appears, gets closer, becomes its sun for a little while.
Wakes it up.
Yeah, wakes it up, makes it release these ancient materials, these unique clues. And we happen to be here to see it. It's such a fleeting visit in cosmic terms, but the potential insights into our galactic heritage, they're just unparalleled.
Absolutely. Yeah. And like Dr. Hopkins said, realizing that 3I Atlas may be the first known interstellar object from the thick disk population. That statement alone really highlights how special this is. It sets it apart.
So yeah, as we wait for October 29th, for that close approach, and for all the data that will pour in, it really feels like the story of 3I Atlas, this ancient messenger, this ultimate time traveler. It's really only just beginning.
It absolutely is. And it makes you think, doesn't it? As we inevitably find more of these interstellar visitors, what completely new questions are they going to force us to ask? Questions about the universe itself, how it all formed, and, ultimately our own place within that enormous history. How might these objects fundamentally reshape how we understand cosmic history? And even the potential for life somewhere else out there?